Is dimensional analysis the only way to solve metric conversion problems? No. One of the things you're going to learn in physics is that there are many roads to Rome. So one way is the dimensional analysis that you learned in the first lecture. But another way is similar to what some of the students in regular chemistry learned with their given and they're looking for. What I'm going to do is show you several ways that you could convert 125 centimeters to meters. Okay, so one is using proportions. We can use our given over our looking for, or find. I think some of you called it find. Okay, so we are given 125 centimeters and we are looking for X number of meters. And so we're going to put centimeters across from centimeters and meters across from meters. And just like we did with the dimensional analysis, we're going to put the 1 with the prefix and its meaning with the base unit. So centi means 10 to the minus 2. So it's still important to know those meanings of those metric prefixes. So then we would cross multiply and divide, and we would find out that 125 centimeters is 1.25 meters. So that's one way we could do the conversion. Okay, so we can use proportions. We can use dimensional analysis. We can also just move the decimal point. A lot of you were taught in elementary school, King Henry did something, drinking chocolate milk, and you just moved the decimal point. Trick was to remember which way to move it. But if we take 125 centimeters, so centi, don't remember centi means 10 to the minus 2. Okay, so what we're going to do is we're going to move the decimal point 2 places in the negative direction. 1, 2, 1.25 meters. Okay, now if you do this on the test, I would like to see you somehow refer to the meaning of the prefix so that you show your work on how you're going to do it. Okay, so it's easy enough when you're just going to the base unit. It gets a little bit trickier when you're going to go between 2 units with prefixes. All right, so let's do this one the 3 ways. Dimensional analysis. Okay, dimensional analysis, we're going to go 500 milligrams. Okay, we're going to convert to the base unit first because we don't know how many milligrams are in a kilogram off the top of our head. But we're going to put milligrams here and we're going to go to the base unit, and our milligrams are going to cancel. 1 goes with the prefix, and milli means 10 to the, look at your notes, minus 3. Good. Okay. So we've converted our milligrams. Now we need to change our grams to kilograms. So we're going to go grams, kilograms. The 1 is going to go with the base unit, and kilo means 10 to the 3rd. So you really do need to know what these prefixes mean. And so that would give us 0.1235 kilograms. That's one way. So that's using dimensional analysis. Using our proportions, we're trying to convert 500 milligrams to kilograms. We don't know how many kilograms that is. Okay, we don't know how many milligrams are in a kilogram off the top of our head. We can figure it out. I'm going to show you how to do that next. But it'd probably be easier if we did this in 2 steps. So if we take away the kilograms and convert to the base unit first, then we put milligrams over grams, because we don't know how many milligrams are in a kilogram off the top of our head. And the 1's going to go with the base unit. Milli means 10 to the minus 3. Cross multiply and divide, and we get that this is 0.5 grams. Okay, we're not done. We have to finish the conversion. Okay, so we need to take those 0.5 grams and we're going to change those to kilograms using our given over our looking for. We don't know how many kilograms that is. Put grams across from grams, kilograms across from kilograms, and we know that 1 kilogram is 10 to the third grams. Cross multiply and divide, and you end up with the same thing we got before, 0.005 kilograms. Okay, so how are we going to do this moving the decimal point? Okay, so we know that kilo means 10 to the third. We know that milli means 10 to the minus third. Okay, in physics and in anything, whenever you're finding the change, you're going to do final minus initial. Okay, final minus initial. So, and we have more of the smaller unit. More of the smaller unit. So final 3 minus a negative 3, that tells us that there are 10 to the 6th, 3 minus negative 3 is 6. There are 10 to the 6th milligrams in 1 kilogram. See that? So we can take this, whoops, and using our given and looking for, we had 500 milligrams, and we were looking for how many kilograms, making sure milligrams are across from milligrams and kilograms are across from kilograms, and we could do that. We could move the decimal point. Okay, so you have more of the smaller unit. So kilograms is bigger than milligrams. Do you agree? So we need to make that 500 a smaller number. How many places are we going to move that decimal point? 6. So we have 500. Okay, we're going to move it 6 places. 1, 2, 3, 4, 5, 6. And so we get 0.000500 kilograms. Okay, more of the smaller unit. That would be a thing to remember to figure out. Okay, which way am I gonna move it? Am I gonna use it? Move it left, move it right, because I'm trying to make this number bigger or smaller. So there's a couple ways to do it. You know, practice. We're gonna practice, and so one of the important things to do is kind of find the way that really works for you. Some of the things that you will be able to do off the top of your head pretty much by the end of the semester is you'll take centimeters and you'll convert them to meters off the top of your head. You'll take grams and you'll convert them to kilograms pretty much off the top of your head. Notice I didn't do this with any of the derived units because it gets a little trickier. So with the derived units, you would want to, if you had kilograms per cubic meter and you were trying to convert it to grams per cubic centimeter, do this conversion in one problem, do this conversion in a separate problem, and then take the top and divide by the bottom, and that'll give you the same answer. But it does get a lot trickier when you have the derived units. We'll work on it, and we'll see you tomorrow.